Okay, so now we do the multiplication by polynomials. So here's the identity. Zero to infinity, e minus st. So what's the trick? We group it together. And we observe that this is nothing else but the derivative in S of this function. Right? And then we swap integral and derivative. Okay, but we can keep doing this. We can keep, grouping things. So e minus st t times tn minus 2. And if you keep doing this, you get minus 1 to the n dts nth derivative and minus st f of t, which is just the Laplace transform of f. Good. Now let's do an example. Solve the IVP. This is first order, so we only need the initial data for y, not y prime. And as always, you can use your formula. So, so s plus 1, and then L of t sine t. So, as done in the previous clips, we have to find this guy first. Here n is 1 in our formula, so we have minus 1 to the 1. First derivative of the Laplace transform of sine. And this is nothing else but, so what is it? 2s s squared plus 1 squared. Okay, because Laplace transform of sine is 1 over s squared plus 1. So y is equal to the following: 2s s squared plus 1 squared, and then times s plus 1. Good. Now we have to do partial fractions. So what do I have? So we have the first guy, minus 1 over 2 s plus 1, My next guy, s minus 1 over 2, s plus 1, s squared plus 1, and s plus 1. Okay. All right. So your strategy should be to get rid of the easy ones, the easy LTs. So this one you already know from the table. So this guy would be minus a half s plus 1, which is just e to the minus t. So that's out. So what was next? Yeah. So another easy one is this. So we have s minus 1, s squared plus 1, minus. And again, you can use the table. So I'll put the half later, but I just want to show you. So the first guy is, actually, let me put it now so we don't forget. Right, first guy is the cosine. So cosine t. And the other guy is just the sine. All right, good. So that's one guy, second guy. So as you can imagine, the toughest guy is this power. Okay. So here we have to find s plus 1, s squared plus 1 squared. Okay. All right, so let me give you two formulas. So using the derivative theorem, you have the following. Laplace transform of t cosine t is s squared minus 1 over s squared plus 1 squared. Or if you do partial fractions, 1 over s squared plus 1 minus 2 over s plus 1, s squared plus 1 to the 2. Okay. And let me write for sine as well, just for completeness. This is 2s over s squared plus 1. Okay, good. All right, so I split this. This is s over s squared plus 1 plus 1 over s squared plus 1 squared. Okay, so this guy can be handled with the sine Laplace, and this guy will be handled with the cosine Laplace. All right, so let me do this slowly. So I guess let me write star to call this star. So star is equal to Laplace inverse of a half 2s s squared plus 1 squared, and then it was 1 over s squared plus 1 squared. So this guy we handled. This is just I have t sine t. Okay. For the second guy, we will use the cosine formula, t cosine. So we do the following. This is equal to, it's a bit long, but stay with me. So this is s squared plus 1 minus 2s squared plus 1. So this is what we want. And then I have to add and subtract this guy. Okay, so I added and subtracted the term I want in order to get t cosine t. Okay, so let me write it here. Minus a half t cosine t. And then I have a remainder term. S squared plus 1. Okay, so that's the only reason I did it. So I can use the formula for t cosine t. And finally, we know what this is. This is the Laplace transform for sine t. Okay, so let me put it together. So this is one term. This is the second term. And then we have to add all these guys. So minus a half e to the minus t plus a half cosine t minus a half sine t plus a half t sine t minus a half t cosine t, and then plus a half sine t. So they cancel out. And that's the solution. And this guy is transient. And this is the dominating term. So it would be something of this form. Okay, thank you.